Hello, everyone. Welcome to INT08, FileMaker of Things, APIs and IoT using Node-RED. I'm very excited to share what I have with you folks today, but before I do so, I have two announcements to make. First, it's important to me that you folks experience what I'm about to show you firsthand. This means we'll be coding together live. There's a high likelihood one of our flows may fail. If we fail, we'll fail forward, and I'll show a video to compensate. Second, this is a presentation on integrations. All integrations require bandwidth, so please, if you can, refrain from running Windows updates and pause your S3 transfers. If any of the requests hang, I'll fill that time with a joke. Some of you may know that I'm the father of 2 children. This means I'm duly certified to tell dad jokes. Should this come to pass, I just want to say, you're welcome. About a year and a half ago, I got really into machine learning. To help myself learn, I wrote an image recognition server. That server was called Big Brother. I used that server to practice securing integrations between the FileMaker platform and a Node.js server, while also exploring practical uses for an image recognition service. It took me about 12 hours to write the server, which, if you're interested, can be found on my GitHub account. And the project ultimately culminated in this. I have a FileMaker file open to a layout with a button labeled Image Recognition. Triggering the button opens up a card window, which I can use to import an image. Once imported, a Classify Image button is displayed. The Classify Image button begins the magic. When the button is triggered, FileMaker Pro sends a Classify Image script to FileMaker Server to process. Because the script uses perform script on server without waiting for completion, my UI is not locked with a beach ball until the very long image classification process finishes. Instead, the data API is used to add and modify the appropriate records given my request. At this point, if we were to gaze up and part the cloud, we would see FileMaker Server sending requests and receiving results through a Node.js server to IBM Watson. Watson analyzes our images and provides FileMaker Server with the classifications it believes best represents my image. FileMaker Server then distills the raw data into a form digestible by the user. The classifications are added next to the image inside the card window. Using IBM Watson and FileMaker grants us access to some amazingly well-trained data models at IBM, while FileMaker provides us with a robust and yet easily accessible way of storing the results. It's quite an amazing pairing. Now, around the time that I wrote this server, I also started working on a FileMaker Node-RED integration. I'm proud to say just a few weeks ago, I was able to recreate and exceed the functionality of that server in under 2 hours. I went from creating a brand new IBM Watson account to polishing the UI in my card window in record time. This has been made possible by combining the FileMaker platform, Node-RED, and an open source project made by a developer in a beach, #vanlife. So I know everyone here has heard of the FileMaker platform, but what is Node-RED? Node-RED is a programming tool for wiring together hardware devices, APIs, and online services in new and interesting ways. It was originally created by Nick O'Leary and Dave Conway-Jones. It is now an open source project at IBM and supported by a community of around 100 developers. Node-RED uses Node.js, itself an open source project, as its foundation. Because of its basis in Node.js, Node-RED can take advantage of Node's event-driven, non-blocking model. Through Node-RED, we will combine Node's event-driven I/O with FileMaker stability and performance. Node-RED is also a very lightweight platform. Under the hood, it's a collection of JavaScript functions and HTML snippets working together. The minimal requirements of Node-RED make it ideal to run at the edge of a network on low-cost hardware such as IoT devices. This means we can use FileMaker as our central repository and source of truth, and deploy Node-RED on the edges of our infrastructure to collect data or receive events. Developers work with Node-RED in the browser. The browser-based editor makes it easier to wire flows together from anywhere. There's no minimum specification required. Additionally, Node-RED also provides an administrative API for programmatic modifications to flows. Node-RED's deployment system also allows rapid development and easy deployment to production. Flows can be deployed to Node-RED's runtime in a single click. Most importantly, Node-RED allows developers to plan their integrations visually. These flow-based programming techniques allow developers to rapidly explore ways to satisfy unique business requirements. Developers can create flows which align with the mapping of a business process. When it's required, Node-RED will also allow JavaScript functions to be created or used directly within the browser-based editor. This gives you direct access to JavaScript where you can solve advanced edge cases. Now, as it turns out, you can't just stick FileMaker and Node-RED together and call it a day. FileMaker has provided the data API, and Node-RED has made it straightforward to use Node.js in a visual way, but neither platform will automatically integrate with the other. So I wrote Node-RED contrib FileMaker. Node-RED contrib FileMaker is an open source project containing a set of Node-RED nodes that abstract the FileMaker data API. Node-RED contrib FileMaker also provides automatic data API session management, and session management allows developers to easily build advanced integrations in a scalable and performant way. This functionality allows developers to use the data API in high-traffic or computationally intensive projects, such as an API source or in a machine learning environment. Node-RED contrib FileMaker also matches the V1 data API while also providing additional utilities to streamline integrations between FileMaker and third-party services. With Node-RED, we can open a data API session, close a data API session, create FileMaker records, get a specific FileMaker record's details, list FileMaker records, edit a FileMaker record, delete a record, upload a file to a container, perform a find, trigger FileMaker scripts, and set global record fields. It also provides additional utilities that enable developers to transform FileMaker responses, retrieve FileMaker record IDs from data record objects or arrays of objects, extract field data from the data API record object or arrays of objects, and download container data. But wait, there's more. Just a few weeks ago, I released Node-RED contrib 2.0. This was a monumental release that added even better session management and adds additional nodes that correspond with the new data API functionality added in FileMaker Server 18. This release adds getting data API engine info, listing hosted databases, listing layouts in a specific database, listing scripts in a specific database, getting layout metadata info, and duplicating FileMaker records. I'm very excited to offer Node-RED contrib FileMaker to everyone in the FileMaker community. The project is MIT licensed and open sourced. You can find this project on GitHub, and I'll provide a link to both the project and all flows used in this presentation towards the end of my session. So you're going to want to stick around. Before we dive in to see just how powerful the combination of Node-RED and FileMaker can be, let's get a bird's eye view of the space we'll be working in. This is the Node-RED browser-based editor. The editor is composed of 3 major sections. On the right is the node palette. Or on the left is the node palette, which contains all nodes installed on the current instance of Node-RED. It also contains a handy search filter, which allows you to easily find nodes via the node's name. In the center is the workspace. The workspace is the main working area. The workspace provides the space to create and store flows. Flows are saved in tabs along the top, and a new flow can be added via the Addition button in the top right corner. To the right, we have the sidebar. The sidebar contains 3 separate areas: the info pane, which includes documentation for the currently selected nodes, the debugger, which shows errors or messages sent from nodes in a flow, and the configuration pane, where we can configure nodes. The Node-RED configuration pane allows developers to manipulate the input, output, and behavior of the currently selected node. This allows flows to be extremely flexible. If an API isn't sending data in the way that we need, we can configure the inputs and outputs to adjust it. Each configuration pane is unique to the currently selected node. With the exception of the special utility nodes, every node-RED-controlled FileMaker node has 3 main configuration sections. The Data API Client section groups properties that are required by the node. With the exception of the utility nodes I mentioned, all nodes require a Data API Client and a layout context. The Node Configuration section groups node settings specific to the node itself. This might include a query property for the perform find node or a container field for the upload container node. Lastly, the Output Configuration section allows developers to modify what properties the node will overwrite or create when adding data to the message object. To begin, we'll start with a very straightforward flow. This flow will create a record in a FileMaker database. Are you all ready? Yeah? All right, let's do it. All flows begin with an initiation event. To initiate this flow, I'll use the inject node. The inject node is a pre-installed node designed to initiate a flow either via a button or on an interval. Later in this session, we will substitute the inject node with other types of initiating events, such as HTTP requests or socket communication. These events will allow us to take actions in FileMaker as a result of a webhook or form submission. I can double-click on the inject node to reveal its configuration pane and provide the inject node with an initiation payload, which I'll make a JSON object and a name, or an empty JSON object and a name. Naming nodes is not required, but it does add to the readability of flows as they become more complex. To visualize the results on our flow, I'm also going to add a debug node. The debug node also comes pre-installed and is used to visualize results or errors in our flow. I'm going to name this node as well. Finally, I'm going to add the FileMaker create node. This node will be responsible for creating a record in our FileMaker database. Notice the red triangle when I add the create node to the workspace. This triangle indicates the node requires configuration. Again, with the exception of the utility nodes, all FileMaker nodes require a Data API Client. In this flow, the create node will use that client to interact with the FileMaker Data API. The client lives in memory, so there are no additional servers or applications to set up. Under the hood, the client is a JavaScript class that contains the logic for connecting with the FileMaker Data API. This class is provided by another open source project, fms-api-client. The client will manage our Data API session for us, allowing us to focus on building a flow to match our desired process instead of extraneous integration details. Choosing the edit icon in the client row allows me to add a client to my Node-RED server. Each client will connect with one database on one server. Should the need arise, I can create multiple clients to connect with multiple databases or servers. Further, each client can support an unlimited number of nodes. We are only limited by the resources available to our FileMaker or Node-RED server. Each client is configured with a server address, a database, and FileMaker account credentials. It's important to note here that the FileMaker account must have the FM REST privilege set enabled. Finally, I'm extremely proud to announce that version 2.0 of this project adds automatic session management. Each configured client will open and manage their own FileMaker Data API sessions. The client will either open additional sessions or queue requests depending on the concurrency configuration. By default, this configuration is set to 1. This means that only one session is allowed to be open at any given time, and concurrent requests will be queued until a session is available. I'm going to go ahead and dial this to 11. This feature allows an unprecedented level of scalability and will allow us to connect a large number of IoT devices or handle a large number of API requests. To finish creating our flow, I must also configure the layout context and some record field data. Each node's requirement should feel familiar to any developer who's worked with custom web publishing. To keep things simple, I'm going to hard code these values directly in the node. I'll set a string for my layout context. And add some JSON for my field data. Luckily, Node-RED provides an editor which I can use to add JSON or JavaScript easily. I'm also going to turn the merge property on. The merge property is specific to the create edit nodes and can be used to merge the incoming data with FileMaker's data API response. This will preserve the incoming data so that other nodes further along in our flow can access them. Now that I've configured the create node, I will link the inject node's output to the create node's input and the create node's output to the debugger's input. By linking the nodes together, I've created a flow. To deploy my flow, I'll use the red button in the top right corner and I'll switch my sidebar to the debugger so we can see the results. I also have a FileMaker database open on the layout of people, so we can watch as the record is created. I can trigger the flow. And perfect, we've created a record in our FileMaker database. Inside the node debugger, yeah, right, it's pretty cool. Inside the Node-RED debugger, I can see the data that I used to create the record, and I can see the record ID and the mod ID. Of course, in this case, the mod ID is 0 because I just created the record. Inside my FileMaker database, we have the record displayed in a user-friendly way. And this concludes my presentation. Just kidding. This is pretty cool, though, right? Combining Node-RED with FileMaker allows me to use the FileMaker platform's powerful toolset in a much more approachable and streamlined way. There's something missing here, though. We have the data. Our flow works from a process standpoint, but what we're missing here is context. The data received represents a person, but it lacks soul. To borrow a phrase, our souls are people. We have to remember that we're building software for people, and software at its best should be imperceptible and empower the user. Great software feels like magic, and we can use FileMaker to provide that magic. We can use FileMaker to query a database and update our record with an image for the person being added. Let's provide a richer user experience by moving to a more advanced flow. This flow will perform a find in the files table of the database and update the person record with an image. We can learn more about each node by hovering over the node inside the node palette. Here it says this node requires a record ID, data, and layout context. For record ID, we mean the FileMaker internal record ID exposed through the FileMaker data API. Fortunately, the developer that supports this project paid particular attention to its documentation. He's a good guy. I can switch to my info pane and select a node to gain better insight into what each property represents. Inside the info pane, we can dive deeper into the documentation. The properties for every node are documented with a name, type, description, and where appropriate, links to the base client documentation. This flow is also triggered by the inject node. But now, data passes to a change node. This change node sets message properties for other nodes in the flow. For this flow, the change node will set a message property used by the find node. Notice we first create the query as an empty object, and then we create a property in that object and set it to the name property. This culminates in a JSON object we can use for a find request. This is a fundamental tenet of working with Node-RED flows. A message, or JSON object, is passed along a flow, and each node in the flow will modify or return a new message until the message reaches the flow's final node. Every FileMaker record can be configured to receive its input from a variety of sources. A node can have an input hard-coded, like we did with the create node. It can read inputs from specific values on the message object, like this find node, or it can read from the flow or global context. The flow context contains values accessible to any node connected in a flow, and the global context is global to Node-RED. The configuration flexibility built into these FileMaker nodes allow them to be adaptable and reusable to almost any need. Moving with our flow, we see that the flow is initiated, the change node sets query layout and data properties, and as before, the record is created in our database, but now we'll perform a find to locate matching files in our database, and then use a switch node to ensure we only update the original record when a matching file is found. The switch node functions like a JavaScript switch statement or FileMaker if-else script step. The flows message will be passed to whatever branch is the first to be calculated as true within the switch. The switch statement here uses JSON-ADA, a JSON parsing strategy, to check if a result array of the performed find contains records. If there are records in the result array, the flow then moves to the next change node. If there are no results, the flow simply ends. Let's follow our flow along, assuming that we will retrieve a record when we perform the find. The flow then moves to another change node, where we set the properties for updating our record. Then we edit the record, and then finally log the results. OK, let me get dad joke number 1 ready. Everybody buckled up? Here we go. Just as before, I'll trigger this flow manually. Awesome. We get a record, and we also get an image. I think the amazing person in this photo would be quite happy that I've included some graphics, something that adds a human element to my data. Well, that's pretty easy, right? Let's review what we have so far. Each node in a flow accepts specific documented input parameters and returns an output message. Input and output parameters can be configured in a variety of ways. This allows our flows to remain flexible. Flows are created by linking node inputs and outputs together. We can use the passing of messages between nodes to shape our data into the form we need. Flows are initiated by events. Events can be anything from a button or a timer to HTTP requests or socket communication. Finally, one Node-RED server can host multiple flows. Deployments are simply a click of a button away, and multiple flows can work together toward a shared goal. Now, while we built this flow, I mentioned that Node-RED Contrib FileMaker is supported by another open source project. That project is called fms-api-client. fms-api-client is an open source project which abstracts the FileMaker v1 data API to provide JavaScript class methods to interact with the FileMaker Data API. fms-api-client grants JavaScript developers easy access to the Data API v1 feature set. It also provides the same helpful utilities for working with the Data API responses you will find in Node-RED contrib FileMaker. fms-api-client has been meticulously documented both in function and form. And finally, something I'm most proud of, fms-api-client is designed to be production-ready at scale and behave in a documented, predictable manner. To achieve this, the project maintains 100% test coverage. So, what's the difference between the two projects? Why are there two? Well, this is what multiple creates would look like using fms-api-client. Seasoned JavaScript developers would feel right at home. We can see, given this example, that the createManyRecords function accepts a client and returns a promise containing individual methods that issue a create request to our FileMaker server, which will finally resolve in a log method. Got it? No, it's crazy, right? In order to fully understand this set of text, I need an incredible amount of specific knowledge. What's even worse is that the knowledge is only applicable to my writing this. My understanding of how JavaScript works doesn't actually translate into building a better process. This is that same set of creates rendered in Node-RED. Instead of being restricted by promise chains or asynchronous callbacks, we're free to explore the process as events on a timeline or flow. I'm proud to say that this is much more approachable. Using this flow-based technique, we can focus our attention to the reasons behind our integration. These reasons will shape our flow and directly inform the process. Now, I mentioned while building our create and edit flow that flows are triggered by an initiating event. Thanks to Node-RED, I can use Node's event-driven architecture to receive HTTP requests and use those requests to interact with the FileMaker database. It turns out that under the hood, Node-RED is really just a collection of Express.js middleware. Leveraging Node's event-driven architecture to connect with FileMaker is nothing new. We've seen some amazing speakers discuss this topic at length in the past. The real advantage to using Node-RED with FileMaker is not technological, but a shift in the developer's perspective. Node-RED allows developers to turn their focus from the technologies that enable them to integrate systems to the process of actually integrating them. When the technological burden of integrations are reduced, developers may refocus their attention from the how to the why. Using Node-RED and FileMaker to build an API, using Node-RED and FileMaker to build an API, we can explore how a focus on the process rather than the scaffolding can yield some amazing results. So I have a database here, and this database has a pretty cool collection of heroes. I believe the heroes contained in this database have done some incredible things, and I want to share this collection with a wider audience. To do so, I'll build an API and website using FileMaker and Node-RED. To create our first API endpoint, I'll add both the HTTP request node and the HTTP response node. A request generally requires a response, so it's quite common to see these two nodes working together. The HTTP request node requires a URL path and an HTTP method. The path of our request node will become the API endpoint. This node will use the path of heroes and a get method in order to trigger our flow. This configuration means that our API endpoint will be available at the Node-RED domain name in the path of heroes. Since my Node-RED server is hosted at FileMakerOfThings.com, the web address would be FileMakerOfThings.com/heroes. I'm also going to go ahead and name this node. Just to be fair, I'll name my response node as well. Wouldn't want to leave it out. Our first API endpoint will list records in a FileMaker database. We'll use the list node to retrieve records for a specific FileMaker layout. As with the majority of nodes, we need to provide the list node with a data API client and layout context. Opening the list node's configuration pane, I can see that there's a default layout and client already provided. I can use the node's default layout, here message.payload.layout, to reduce the amount of configuration I do moving forward. Instead of hard-coding the layout context in each node, I'll use a change node to set the value for the entire flow. So I'll set message.payload.layout to people API. Now I can link these nodes together, deploy, and we can check out the results. You guys may be getting a dad joke. There we go. OK, game on. OK, so I'll use Chrome here. And I'll visit the URL, which is https:/filemakeroftthings.com/heroes. Awesome. In under a minute, I created a FileMaker-supported API. Thank you. Notice that my flow is aligned with the process of listing records. My first node receives the request. The second node sets the layout context. The third node retrieves the records using the context. And the final node sends the records to the requester. The ease and speed of constructing this endpoint didn't come from some advanced new technology, but rather the reduction of unnecessary code scaffolding and the focus on the process. Now, I don't want my API to simply return JSON. I want to use FileMaker to support a full website. So let's take this a step further. We can combine FileMaker, Node-RED, and Mustache templating to build a full set of web pages. When the FileMaker Data API returns data, it returns record field data and portal data inside of an object. To reduce the complexity of constructing our first web page, we can use the transform node to flatten the FileMaker response. The transform node is a utility node that will remove non-field data properties and streamline our data for our template. Because the transform node is a utility, it is one of the few nodes that don't require a data API client. The transform node simplifies and generalizes our FileMaker data so that it is easier for third parties to consume. For our specific purpose, the transform node will make templating our data with Mustache much more straightforward. To construct an HTML response, we'll also add the template node. The template node is another pre-installed node, and it'll convert our JSON payload from our list node into an HTML response. And would you look at that? I just so happen to have HTML just laying around handy. I mean, you never know when you're going to build a FileMaker website, right? Inside the HTML, we have some some values quoted with curly braces. These curly braces are our mustache syntax. Mustache is a logic list template syntax, and it works by expanding tags in a template using values provided in a hash or an object. The curly braces and values will be replaced with matching values or tags in the message payload. For our purposes, this is the list records that we get from our list node. This HTML template will allow us to build a list page. Now that I've added the required HTML, I can deploy, and we can bask in the glory that is my fully styled website. Pretty cool, right? Still, we can make this even better. FileMaker has the ability to store large amounts of binary data. Things like images, text documents, or audio files can all be stored and curated using container fields. I can use the web to share my heroes, but what about using the web to receive content? It turns out that I can use the web page we just built to offer my viewers the opportunity to enhance my content. Let's take a look at the flow that allows users to upload images and those images to be stored in my database. This flow adds a few more rows of nodes to the previous flow to enable the uploading of files. Just like before, we have an HTTP request node. In this flow, the HTTP request node accepts a post request and allows the uploading of files. Once the file has been received, I will set layout context and configure container data to place our image. Since I want to save resources on my Node-RED server, I'll use a buffer payload and configure the correct object using the function node. The function node allows us to write pure JavaScript within a flow. In this flow, the function node will construct the file object much like a FileMaker let calculation. Since this endpoint will not be user-facing, we don't have to add a transform node or an HTML template. Now I can navigate back to my website and select one of the list items to view that record's details. Notice the URL contains the UUID of my record. Instead of exposing the internal record ID of my FileMaker record, we're using a perform find to find the record with a matching UUID and serving that record's content to the viewer. This allows our web page to remain flexible. Now, I have 3 images on my desktop and an upload area on my website. I'll also open my FileMaker database to a layout where we can view the files. I can drag all 3 files at once, and they'll be automatically queued, uploaded, and curated by FileMaker. FileMaker will also automatically retrieve container information for each item uploaded. Now, last DevCon, Robert Halsey got up on stage at the keynote and showed us all how to connect IoT devices with FileMaker, live, on stage, in front of hundreds of people. In that moment, my love for robotics and lower-level hardware was renewed. In fact, my journey with tech started with robotics many, many years ago. I learned C at a very early age, and I was introduced to robotics via the first robotics competition. Shout out to my team, Team 358. It turns out that IoT prevents some unique challenges and specific issues. IoT, or Internet of Things, is intentionally plural. The nature of IoT is that there are many different things, and each thing in my internet could be a different device, coded in a different language, or require a different set of instructions. To make the situation even more complex, the things in my internet are rarely aware of each other or the state of the system they're communicating with. Each IoT device usually focuses on only one concern, but a business often has several. It is rare for one device to fill all of a business needs. It is more common for many different devices to provide the required data. This means managing infrastructure that can cater to each device's requirements. Further, because IoT devices function at such a low level, they are often iterated on. Hardware is quick to go out of date, and to use newer, more advanced hardware, you're forced to update quickly. Working with IoT means working with many different languages. Each language performs a specific function within the overall IoT infrastructure. C is common on the hardware level for embedded software on the device itself. Python might be employed to process incoming data at scale. And web languages like JavaScript or PHP might be used to handle the request between the devices and their collection point. Most importantly, IoT devices generate a large amount of data. It wouldn't be uncommon for tens or hundreds of devices to send multiple messages within a few seconds. At scale, this would be a concern for our data collection point. The FileMaker platform offers some great counterpoints to the hectic nature of working with IoT devices. The platform's strengths allow us to overcome some of the challenges working with IoT. The availability of the FileMaker Data API allows for an efficient and robust collection strategy for a large number of devices. Beginning in FileMaker 16, the entire platform now speaks JSON natively. FileMaker's fluency in JSON, the de facto language of the internet, adds to its already amazing integration points. FileMaker Pro and Server work together to provide a stable and distributed user interface to users. Server and Pro will work together to provide data to users in real time without much effort from developers. As we've seen using the perform script on Server, this allows complex process of syncing information to happen in the background. This preserves the user experience while also providing a communication channel when critical events are triggered. In the field, FileMaker Go has the ability to connect to devices that may not be available to an external network. We can use insert from URL to communicate directly with the device or locally bound Node-RED instance. Now, I'd like to consider myself something of a maker. I enjoy solving complex problems through innovation. FileMaker provides me with the stability and extensibility I need to experiment. Here, I have up my FileMaker database. This database is designed to store IoT devices and the events that they generate. This database will be made available after the session for everyone to use. As we saw at the image recognition demo, I can use a FileMaker script running via perform script on server to asynchronously connect to the Particle Cloud and keep my devices up to date and easily accessible. Now, I have quite a few devices, so this process does take a minute or two. While we wait for the devices to populate, let's take a look at the flow that supports this function. The sync button in FileMaker uses perform script on server to call a URL. Again, the combination of perform script on server and the FileMaker Data API allows the many parts of my infrastructure to process the task of syncing devices to the user interface in the background. A user never needs to wait for the task to complete. This HTTP request accepts a GET request on the path of devices. Once the flow is triggered, the flow then sends a request to Particle's Cloud, which will return an array of devices. The flow will then split the array into single device objects. For each device, we build a query based on that device and perform a find to see if the database already has the record. Using a switch node, we can check if our perform find contains results. If a device record is found, we'll edit the record, and if there are no results, we'll create a new device record. Performing a find and then either creating or editing the records ensure that our devices stay in sync and prevents duplicate records to be created. Since this work is being shared between Node-RED and the Data API, the user's FileMaker Pro client is free to focus on whatever task is most important to the user while the device is being collected. Lastly, we rejoin the devices we split earlier, then check to make sure we have a response request, populate it, and then send the response back to FileMaker. All right, let's take a look and see if our devices have synced. Awesome. I have 18 devices that have now synced to my FileMaker database. Notice the red and green dots next to the device's name. This indicates the device is online. Because updates happen in the background with the Data API, a device's online or offline status can change, and the UI will be updated in near real time without the user needing to sync devices again. Now that we have devices in our database, we can see the events that they generate inside the portal at the bottom. Events are collected in Node-RED and sent to FileMaker via an event subscription. Using the incoming data's device ID, FileMaker will automatically organize the events and display them per device. Let's take a quick look at the flow which provides event collection. This flow is rather straightforward. It uses the particle cloud node to listen for incoming events for my devices and creates a message object for each event. We then set layout context and create a record for each event. On the database level, FileMaker will use the device's ID to relate the events to the appropriate device. The ease and simplicity of this flow showcases the power and processing of using Node-RED and FileMaker. There's no complicated process that must be followed or backend code to set up. If anyone would like to dive deeper into IoT, I highly recommend you visit the hands-on workshops available this week at 1:30 in Miami 1 to 3. In those workshops, you'll get to use this same file I used in the presentation. Before we wrap up, let's circle back to the image classification flow I showed in the very beginning. Now that we have a good understanding of how Node-RED and FileMaker can work together, let's take a look at the flow and see how we use IBM Watson to classify our images. Like the sync devices flow, the classify image flow is triggered via an insert from URL script step running via perform script on server. While the sync devices HP node used a get method, this node uses a post method. The post method will allow us to send the device record's ID with my request. The flow will then use the device's ID to create a query and then use that query to extract the container data image. To retrieve the image from the record's container, we also convert it to a file buffer. Once the buffer object is created, we send that buffer to IBM Watson's classify image node. We then set that node's results to the flow's message object. The flow then splits the results into separate message objects. While this occurs, we'll also update our classified timestamp so we know the last time our image was classified. This allows us to keep track of our images. And when Watson returns an image classification, it returns more of an array of classes for each image. It actually returns both the classification for an image and an overall classifier object. The classifier object will allow us to build custom image recognition classifiers to identify both specific people and things. We can use FileMaker to train custom classification models. This means FileMaker can, over time, teach Watson how to better classify images. Before we dive into updating classifiers, let's take a look at the middle branch of our flow. The middle branch uses the same strategy we saw in the sync devices flow. For each class, we perform a find using the classification type, name, and the ID of the image. If the classification does exist, we won't create a record, but if it does, or if it does exist, we don't create a record, but if it doesn't, we will create one. This process both relates the classification to our image via the image record's ID and ensures that we never duplicate classifications. Moving back to the topmost branch of our flow, we have a similar but slightly more complex set of nodes. This set of nodes creates or updates the classifier records in our database. First, we set the classification layout. Then, we split our classification array so we get one classification per object. Then, we use each classification message to construct another query. If the item exists, we'll use the extract record ID utility node to identify the correct classifier and update the model. If the classifier doesn't exist, we simply create a new classifier record. Everything in this presentation and the presentation itself is open source and available online at these 3 links. I'm proud to offer Node-RED Contrib FileMaker and fms-api-client to my friends and colleagues in the FileMaker community. Both projects are MIT licensed. I believe that when we come together, we are capable of some great things. To that end, I offer these tools. I want to take a moment to thank everyone at Claris for providing an amazingly capable and incredibly extensible platform. Without their work, none of my work would be possible. My name's Lou DeLaPara. I'm proud to be a small part of the team at SeedCode. If you're interested in my work, you can find me as LouDog on GitHub. Thank you very much. If there's any questions, step up to the mic.
Thank you very much for the presentation. I really enjoyed it. How does one get started with Node-RED? What's required to install? Where do we get started?
So the question is, how do I get started with Node-RED? So you can actually just go to Node-RED's website to get started. But if you are really interested, head to the hands-on workshops that deal with IoT. They'll be at 1:30 on Tuesday, Wednesday, and Thursday. Within that workshop, you'll actually gain access to the file that I used today. Inside of that file, there's a link which will allow you to install Node-RED locally, and that'll allow you to actually get started fairly quickly.
Thank you. As somebody that's used your nodes in Node-RED already, it's fantastic. So
thank you.
It is as easy as he makes it sound. Can you give some of your thoughts on deploying Node-RED in production, hosting it in the cloud versus on the same box as FileMaker server? Or?
Sure. So the question is, what are my thoughts on deploying a Node-RED server in production at scale? And so my particular way of doing that, I generally run an Ubuntu instance on an AWS instance. I like to use what's called PM2, which is Process Manager, to keep the Node-RED process open. And then I deploy with the programmatic API. That's a lot, right? So what I'd say is if you're getting started or you have a smaller project, you can run Node-RED right alongside your FileMaker server. When the FileMaker Data API was announced and released, they actually included it with Node.js on the server. So you can just install Node-RED on your FileMaker server if you're looking to just get started, and then move to a bigger server once you go into production.
Thank you.
Thank you.
Thanks for the presentation. I have a question. Will it take care of dynamic forms like we do in PHP, HTML?
The question was, would this take care of dynamic forms?
Yes.
Yes, it would, but I'll caveat that by saying you'd still have to construct the HTML. Just like you would construct it within PHP, you would do so just as you would do the mustache templating that I showed in the middle part of the presentation. So you'd create a form via HTML, use that form to submit to an HTTP request node.
OK. Yeah, thank you.
Thank you. Thanks, everybody. It was a lot of fun.